In this video, for molar gas volume. In the previous video, but I'll start from here. Now, let's start. When you talk about molar gas volume, what it means is the volume of gas occupied by one mole. So, a molar gas volume, that's the volume occupied by one mole of gas. Palizinthu ziwiri, it can either be at standard temperature and pressure or at room temperature. So at room temperature and pressure, the volume occupied by gas, that's 24 liters or 24 cubic decimeters. At room temperature might 25 degrees Celsius, and if you convert that one into kVs, that's 298. Remember, 0 degrees is equivalent to 273, and if you add here by 25, the answer will be 298 kVs. And at room temperature, pressure is 1 atmosphere. That's 1 atmospheric pressure. Now, to find the number of moles of gas at room temperature, the formula is this one: volume of gas divided by 24 cubic decimeters. So we'll be using this formula in calculating the number of moles of gas at room temperature. Mass volume of gas is just a matter of making volume subject to the formula. The times 24, and the answer will be volume of gas is equal to number of moles times 24 times 3. When it comes to standard temperature and pressure, the volume of gas is 22.4 liters, and standard temperature, that's 273 kelvins, which is equivalent to 0 degrees Celsius, as well as standard temperature as well. Standard pressure, that's 1 atm. So to find the number of moles at room temperature, at standard temperature, that's the volume of gas divided by 22.4 times 3. And to find the volume of gas, that's the number of moles times 22.4 times 3. Now, let's see examples. The first example reads: work out the number of moles of carbon dioxide, CO2, contained in the 6 dm3 of carbon dioxide measured at room temperature. At room temperature, the community bang solution, mind you, at room temperature and the pressure, volume, you mark 24 dm3, that's our volume. Here it's 24, that's 24 dm3. So to find the number of moles, so at the room temperature and the pressure, number of moles is equal to the volume of gas, that's the volume of gas, that's our carbon dioxide, it's 6 dm3 divided by 24 dm3. So our answer, if we divide that one, I think it should be 2.5 moles. Yeah, that's 2.5 moles. That's the answer there at room temperature and pressure. This is the volume of gas contained in, the number of moles contained in this volume of gas, 6 times 3. Let's see another example. It reads: how many moles are there in 24 cubic centimeters of hydrogen at room temperature and pressure. So what we need to do, you have to know, sorry, this is the solution. So solution, at room temperature and the pressure, the volume is 24 dm3. This volume in cubic centimeters, you have to convert that one into liters or dm3. Remember the volume in dm3, then we have to convert that one. So conversions go like this. 1000 cubic centimeters is equal to 1 dm3. What about the 23 cubic centimeters? Angati. Living with the banga, just a matter of cross multiplication. This one times this one, and that one. So here it's x times 1000 cubic centimeters is equal to 23 dm3. Not 23. Here it should be 24. That's 24. 24 cubic centimeters times 1 dm3 here. Negative with the ground 1000 cubic centimeters, also 1000 cubic centimeters. So this one will cancel. Cubic centimeters will cancel, and our value of x here, it will be 0.024 dm3, this guy. So that's the volume represented here. Now I don't know what it is, the number of moles at room temperature. So what we need to do, given volume, number of moles, sorry, not volume, but number of moles. So number of moles is equal to our volume, that's 0.024 dm3 divided by 24 dm3 at room temperature, and if we divide that one, the answer will be 0.0001 mole. So this is the answer here. Let's now see another example. It reads, what is the volume in cubic centimeters does 0.25 mole of oxygen occupy at a standard temperature and pressure? So solution, take a formula at a standard temperature and pressure. Number of moles is equal to volume of gas divided by 22.4 dm3. So to make the volume of gas, subject to formula, negative volume of gas here, volume of gas is equal to number of moles times 22.4 dm3. So we have been given the number of moles here, that's a 0.25. So 0.25 moles times 22.4 dm3. So our volume, after we multiply there, our volume, that's 5.6 dm3. That's the volume, but the question, it says we have to find the volume in cubic centimeters. So from that conversion, 1000 cubic centimeters is equal to 1 dm3. that's 1 dm3, and then we need to find cubic centimeters in 5.6 dm3. So here we just put x and then cross multiplication. So that one is x times 1 dm3 is equal to, if you multiply this one, you get 5.6 dm3 times 1000 cubic centimeters. And then here we're going to divide the 1 dm3 both sides, also 1 dm3 both sides. So this one cancel, dm3 cancel, and if you multiply that one, our x will be, should write it here, our x is equal to 5600 cubic centimeters. So that's the answer here. This is the answer. Ahead, let's now see another example. Another example, it reads, what volume of gas does 22 grams of carbon dioxide occupy at room temperature and pressure? Lam ndimene yatipatsa kuti C ndi 12, winayo ndi 16. So solution of that one will go this way. Number of moles, we need to find number of moles. So number of moles is equal to mass over RFM. So our mass is 22 grams divided by RFM, carbon dioxide, it's CO2. Then was already carbon in the moles, we can 1 times 12, then plus oxygen, carbon dioxide, so we can 2 times 16, and then if you add there around 12 plus 2 times 16, that's 32. Tikazaphatiriza lamu ya family RFM is a 44 grams per mole. So here we can 44 grams per mole. The gram will cancel, gram will cancel, and the answer there will be 22 divided by 44. The answer is 0.5 moles. So this is the answer in terms of the number of moles. And when we want to find the volume, mind you, volume of gas is equal to number of moles times since I'm about at room temperature, that's 20. Should be 24 dm3, that's 24 dm3, and our number of moles is 0.5. Then this other one is only 24 dm3 here. Now if we need 0.5, it's the same as a half, and half of 24, that's 12 dm3, that's written here. So that's the answer. We are done with that. The next thing you will find, it's about water crystallization. Water crystallization. When you talk about water crystallization, you learn was about the water present in crystals of some salt compounds. And how is in what about the order of hydration? Mind you, hydration means there is water present there. So order of crystallization, that's water which is present in some crystals of some compounds. Zindizima kabudi mina zanyo, right? Zindi madzi inside it. They need to do that. Zitsanzo maizo tindi copper sulfate, copper 2 sulfate pentahydrate, copper sulfate 2 pentahydrate. Mind you, masotsiwa dzina lina amachidwa ma hydrates kapena kuti hydrated compounds ndi chitsanzo chathu choyamba ati ndi copper sulfate 2 pentahydrate, and in exams nthawi zina amatha kufunsa kuti ulembe formula of this one. So copper sulfate, our formula for copper sulfate, that's CuSO4. Remember, copper the Cu2 plus, and the sulfate that's SO4 2 minus. In the previous video, number mwinga kalo 2 in the 2, that's 2 kalo, that's 1. So here it's 1. Pumu 2 alavari, kalo 2, that's 1. So this is the thing. Then, since it's pentahydrate, penta means 5. The hydrate it's water, the matter 5. So it's the formula, it's that one. CuSO5, SO4, then dot 5 water molecules. And another one, it's magnesium sulfate heptahydrate. Magnesium, that's Mg2 plus, that's its valence. Sulfate, the number 2 minus 4, and the number is 2, that's 1. Sulfate, that's 1. Look at magnesium, phonica modes, take magnesium modes, sulfate this one modes, then dot hepta, it's 7, so you can 7 H2O. So this is salt, hydrogen salt, that's its formula there. And the other one is sodium carbonate. Sodium carbonate, sodium, that's 1 plus, and the carbonate is CO3 2 minus. Number mwinga kaloya hapa, iloya hapa, number biya kaloya yusa kaloya plus and 1 kali, so that's 2. 1 kaloya 2, that's 2, and 2 kaloya 2, that's 1. The would be sodium carbonate, it's Na2 again, then carbonate CO3. Therefore, that would be deca. It's deca. They would be deca and 10. These are 10 water molecules here. So that's the formula here. Those are the examples. Now let's now determine the percentage of water in molecular and hydrogen compounds. The bank of percentages. So and now we calculate the percentage of water of crystallization in sodium carbonate decahydrate. So that's the formula to get the percentage of water. We need to find mass of this compound. So Na2CO3 10 H2O. Tigezi kuri branch. The sodium alipo mwili, so ika 2 times it's 23 here, take 23, and then it gives into the wire. The switch to blue there. Then plus carbon alipo mozi, so it's on color 1 times 12, and then plus 20 oxygen alipo mutatu, so oxygen alipo mutatu medivanga 16 times 3, and then plus water alipo 10, ndi ya hydrogen bayoka, that's 1, ndi tingopanga 2 times 1 here, then plus oxygen, that's 16, ndi kulava 2 plus 16 as 18, ndi kuti water alipo 8 alipo 10, ndi tankha 10 times 18 here, which is 180. That's 180 there. Ndi kulava zangu phatiza ndi 180 this gut. So if you add here, that's 46. After multiplying here, that's 46. Here it's 12. plus 48 here, then plus 180. This is the sum of that one. Tikapanga yonse 46 plus 12 plus 48 and 180. This one, that's 58. 58 plus 48 plus 180. The answer is that's 286 AMU. So that's the mass of that sodium carbonate decahydrate. That's the mass there. So to find the percentage of water, to find the percentage of water is equal to mass of water crystallization, divided by mass of the compound, compound times 100%. Times 100, that's 100% here. Engagement bangi, mass of water inaweza within the mass of water inaweza within 180, so 180 over total mass is 286, then times 100 times 100, and after everything 180 times 100, that's 18,000. 18,000 divided by 286. The answer is 62.937%. So this is the percentage of water in the compound. Let's now see another example. It reads on heating 1.250 grams of hydrogen barium chloride, 1.060 of anhydrous barium chloride remained. The percentage of water crystallization. What anhydrous? There would be another size. Kuzumitsa zitauma that's anhydrous. What anhydrous? There would be chauma. Water has been removed there. The chimeti bange total mass atipatsa kuti total mass atipatsa ndi 1.250 gram, and the mass of anhydrous mass atipatsa kuti ndi 1.060 gram. Ndikuti mass of water madzi amene anapanga evaporate, mass of water here is equal to mass of water chimeti pange tingochotsera, that's 1.250 gram minus 1.060 gram, and if you subtract here the answer is this one, that's 0, and you subtract 5, 15 minus 6, that's 9, and here this and 1 term now go 0. So this is the mass of water which evaporated. So to find the percentage of water, percentage of water is equal to mass of water divided by mass of hydrated compounds. The kapena kuti total mass. So mass of water that is going to be 0.190 gram divided by total mass, and it's that one, which is 1.250 gram. Then we're going to multiply this by 100. And after everything, take a time 0.190 times 100. and then answer dividing the 1.250 gram. The gram will cancel. Answer is 15.2%. So that's the answer. Pamenso amatauso kufunsa mbwenu inabulabo ngati yesi kale kunjaje. Kubanga determine how do you determine the percentage composition of water in such salt, in such hydrated salt. Amatauso kuti ubanga outline steps involved. So chimeti pange tikukuza ni steps yake which are involved komanso zimene buku yanalemba. Mind you, if you're enjoying this video, don't forget to subscribe my channel. You can also share, like the videos, or also comment. Let's now proceed. There is this question. They even formulated in that way. Describe how you would determine the percentage of water in hydrated copper sulfate. In hydrated copper sulfate. I'm going to go to hydrated. We don't know what the amount of water present is there with the mass second bunch. But what we know here, copper sulfate is just a hydrogen. It means it contains water. So we have to find the steps creating up in the bunch. With the percentage of water present in that salt. So this is the solution. Chofunika materials again. Tibona kandi hydrated copper sulfate solution evaporating basin kabina bitini tikandi bana being balance to measure table stand komanso wire goes tikanazi zimene kazo. So those are the materials required. Now chimeti pange we're going to weigh the tin on the beam balance and record the mass. So let's just assume kuti tin yo taiyeza kuti kulemera 5 grams. Tin kulemera 5 grams. Tipanga record. Then after that, we need to add the crystal of hydrated copper sulfate. Let's say kuti tin yathu ndi imeneyi. Ndikuti mu tika mu crystal zaife. You want to be balance life. The tikapanga add minimum tipanga record mass. Let's say kuti after adding mass inazeka kuti ndi 35 grams. Ona tanto kuti tapanga weigh zonse yazeka kuti 35 grams. Total mass of tin ndi hydrated copper sulfate. We need to find the mass of hydrated copper sulfate. Which made the tin the hydrated copper sulfate. Now this is good in the assume 35. So here tipanga 35 grams minus mass of tin 5 grams. Then our hydrated copper sulfate here equal 30. That's 30 grams. That's hydrated salt mass yake. Now chomwe tipange tikapanga grade choncho, we are going to heat the tin. Tipanga heat zipanga kuti kuumitsa tizomitsa zinthu zabwino until sulfate life ijayo itani isinthe khale pa engine powder, white powder, ndikuti madzi acho kama ikhale white powder, ndikuti madzi acho evaporate. The next thing we need to do is to weigh the tin plus white powder. So taumitsa ndi after kuumitsa tilekeze kuti yadzapeza kuti ndi 20. Zingine zathu zija zapeza kuti ndi 20 gram. We tangopanga assume kuti that's 20 gram. Ndikuti chomwe tipange we can now find the mass of the white powder. Mind you, tapanga weigh zinthu zoti madzaja evaporate yakwana kuti ndi 20 grams. Ndikuti mass of the powder chomwe tipange tingochotsera tingopanga 20 gram minus mass ya tin ija inapeza kuti ndi 5 grams. Tin yonse inapeza kuti ndi 5 grams. So tikachotsera chimene answer idzakhala 15 grams. Answer it's 15 grams. So 15 grams, this is the mass of hydrated, anhydrous sorry, that's anhydrous powder. That's our powder. The next thing we need to do, we need to work out the mass of water. The mass of water. So mass of water, formula again. Mass of hydrated salt minus mass of powder. Mass of powder. That's powder. Sorry, spelling a powder. So powder. The mass of hydrated salt with it's mass of hydrated salt. Where is it? Mass of hydrated salt. That's 30 grams. So 30 grams. So here is 30 grams minus mass of powder. Then I'm going to 15. So take a 15 grams here. And then next thing we need to do to go to Sarah. Let it go to Sarah. Then put our mass of water of the 15 grams. So that is a minimum. So to find the percentage of water that you be going to make you can mass of water over hydrated salt. That's our over sulfate. Then we mind you, times 100 here, 100, and then tumodivanga mass of water now is wouldn't be 15 grams over 30 grams times 100. Grams will cancel. 15 into 30, that's half, and half of 100, that's 50. So answer is 50%. 50%. That's our answer. That's the percentage of hydrated. Percentage of water in hydrated salt. So that's the thing there. And for this one, that marks the end of our discussion. And the next time we meet, tivagambira nazokuza ndi empirical formula. Tivagambira za empirical formula of a compound. Tivagambirani kuti empirical formula ndi yani. Komanso how can formulate empirical formula from given information. So that's it for this video. But please don't forget to subscribe to my channel. And if you have any question in chemistry, biology, or whatever question, you can hit my number on WhatsApp. You can get a video. I will formulate a video for you. So that's 082455562. That's my WhatsApp number. You can need Bangali Chunigu. You can get a video. No, my sorry, but so that's it for this video. Thanks for watching, and have a nice play.